Okay, I suggest you read this question and press pause while you do it, and I'll start the working very shortly. Okay, so here we're told the first term is 440. Well, that means A is equal to 440. And we're also told something about the 12th term, but for the moment this is what we can say. The geometric sequence that leads to the series is going to be 440 times r to the power of n minus 1. And what we'd like to do now is find a value for r. Now we're told that T12 is equal to 880. Now I hope you can see that one of the implications of this is that 880 must equal T1, or A, times r to the power of 11. Okay? So to get from the first term to the 12th term, you're going to multiply by the common ratio successively, in other words, by r to the power of 11. So that means r to the power of 11 will equal 880 divided by 440, which of course equals 2. And so to find the value of r, we take the 11th root of both sides, and we come up with an approximation of 1.06504. Okay, now we want to take it to a few decimal places, because when we raise decimal numbers of that form to a lot of powers, we lose precision every time. So I'm taking it to, 1, 2, 3, 4, 5 decimal places in this case. Okay, now our job here is to find the sum of the first 6 terms. The sum of the first 6 terms. So let's get rid of that for the moment a bit and go about that. Okay, so now r is above 1, isn't it? It's more than 1. So we're going to use this form of the formula. Sn is equal to a bracket r to the n minus 1 over r minus 1. Okay, so the sum of the first 6 terms by simple substitution is a is equal to 440, we discovered. R is that awkward decimalised number, like so. And n, so we're finding the sum of the first 6 terms, so n is 6, and we subtract 1 from the end, over 1.06504 minus 1. This down the bottom is quite easy to evaluate. The denominator is easy to evaluate because you're just taking 1 from here, so it's going to be 0.06504. Alright, and with your calculator you are going to discover that the sum of the first 6 terms is equal to 3,108.4 to 1 decimal place. And that's the end of that problem. So again, you might want to press pause while you read this question. Okay, our job here is to find S1. Now that's the same as finding A, isn't it? And S10, so the sum of the first 10 terms, if the 5th term is equal to 1 and the 8th term is equal to 8th. So what we know already is that the 5th term, T5, is equal to 1 and T8 is equal to 8. Now to get from the 5th term to the 8th term, you are going to have to multiply the 5th term by r to the power of 3, aren't you? 8 take 5 is 3. So we can say that. We can say 1 times r to the power of 3 is going to get us to the 8th term, which is 8. Okay, so here we can say, taking the cubed root of both sides, we can say r is equal to 2. And there's no negative possibility because we are dealing with an odd power. Okay, so now what we need to do is find the sum of the first term. Well, that's the same as finding A, isn't it? So How we do that is use a kind of reverse logic to what we used here. If we are going from the fifth term down to the first term, we're going to need to divide the fifth term by r to the power of 4, aren't we? 5 take 1 is 4. So we can say now that a is equal to 1 divided by r to the power of 4. But r is, of course, 2. So therefore a is going to equal 1 over 2 to the power of 4, which of course equals 1/16. Okay, so where are we? We have in fact answered this part of the question. We found S1. We found S1, which is the same thing as A. Okay, we've got a value for R, so all we need to do is use our formula and substitute values for R, A and N in to find the sum of the first 10 terms, and N is going to equal 10. Okay, so let's just move this out of the way for a bit and proceed. Okay, so Sn equals A r to the n minus 1 all over r to the minus 1, and so the sum of the first 10 terms is going to equal A, we said, was 1/16. R is 2, and we're going to raise it to the power of 10 because we're finding the sum of the first 10 terms, over 1 and over 2 minus 1. Very good. Now notice that the denominator here, that's going to come to 1. And notice something else. This 16 can come down to become the new denominator. Okay, so that's quite a handy thing to know. So what we're going to do now is say that s to the power of 10 is equal to 2 to the power of 10 is 1024. And we're going to subtract 1 from it, and we are going to bring the 16 down. Okay, so S10 is equal to 1023 on 16, which equals 63 and 15/16. And that's the end of that problem.